Welcome. If you are watching this video right now, it is because you and your group have been assigned Dataset 1. And as we go through this video, I'm going to kind of read this and try to explain this to help you understand it as much as possible, as well as see what's going on in the graph off to the right over here. Recall the first thing you should do when you're looking at a graph or data table is actually look at the x and the y axis. So what we see going on our y axis is that we're looking at the number of dividing cells, and when we think of the word divide, you should probably be thinking of the word split. So we're looking at how cells split. And then looking at our x-axis, we can see that is labeled as ZT, which I'm not exactly sure what that means yet. Perhaps our text will help us out with that. One thing I do want to mention and point out to you, because it's really kind of hard to see on your paper because it printed in gray, is this bottom region here, healing accelerating phase and healing delayed phase. On the picture that's colored, there would be a split right here at about the 7 mark, where this region from here to here would actually be the healing accelerated phase, and then this is another color. This region over here would be the healing delayed phase. That might be helpful in your thought process as we go through this. Now let's take a look at our graph. We've identified this section here as being the healing accelerated phase, and we can see that the number of dividing cells or number of splitting cells, it's increasing during that time. And then once we get to 7, we can see we are entering the healing delayed phase, where the number of splitting or dividing cells is decreasing. All right, let's take a look at the text. The graph to the right shows us wound healing. So wound healing, when I hear wound healing, I'm kind of thinking of when I might get a cut. And mitotic rates. I don't know that. Mitotic rates, it is how quickly cells reproduce. So I'm going to just draw a little arrow pointing to it because I found the definition of mitotic rate. So it's looking at the mitotic rate in the damaged cornea. There's another term that might be tricky in understanding, but it also looks like the explanation is provided right here. The cornea, it is part of our eye. So if you did not know that the cornea is part of our eye, now you do. We are looking at this part of the eye in, looks like a mouse. The level of DNA replication, okay, there we see another term, DNA replication. I know what DNA is. I know that we have it. I know that it determines things about me. Replication is a term that I'm familiar with. That means to copy. So when I see DNA replication, I must be thinking about something with DNA being copied. So I was looking at the level or amount of DNA replication in corneal epithelial cells in mice. Not quite sure what epithelial means, but I do know what cells are, and I know what the cornea is, so I'm looking at cells in the cornea. So the level of corneal cells copying in mice, it's high in the morning and low in the afternoon, evening. So what we see is the rate is fast early, and it is slow later in the day. As a consequence, injury in the morning is expected to lead to accelerated entry into mitosis, making new cells, and wound repair compared to injury in the afternoon, evening. Shaded areas indicate dark periods, and ZT stands for Zeitgeber time. So now I know that this is talking about time. And since I see 1922-147, it looks like the Zeitgeber time is using a 24-hour clock, which I kind of learned when I was younger. I called that Army time. So that means that 11 o'clock must be around like lunchtime almost, if 12 is noon. This must be then 7 a.m. This must be 4 a.m., 1 a.m., and this must be late in the night, early morning. So what you are asked to do now is use this information to help us answer this question. What does this help us understand about cells? Answer that question with your claim, and then find evidence up here that will support your claim that you can share down here.